Okay, today we're going to talk about polynomial functions. A reminder about polynomial functions is they are continuous functions. That means they go on forever. And with polynomial functions, they are all going to look in general form, look like this. And they are continuous functions, so that means that all the exponents are whole numbers. There's no variables in the denominator and none under the radical. And so that implies that the domain then is going to be all real numbers. So we don't have to worry about dividing by 0, we don't have to worry about taking the square root of a negative number. So also with polynomials, you can have a constant polynomial or a zero polynomial. That would be like 12. And so let's look at some other specifics about polynomials. That the degree of the largest term, so like here it says 6x to the 7th plus 4x cubed plus 5x squared minus 7x equals plus 10. So the degree of this is 7, the degree of the largest term. The leading coefficient is the coefficient of the largest term, so in this case that would be 6. And our constant term in this case would be 10. So here's some examples here of polynomials. So in this chapter we're going to be talking about polynomials, we're talking about zeros, and all the specifics about polynomials. So here's a definition of a polynomial function. A function whose rule is given by a polynomial, where all of the coefficients are real numbers and all of the exponents are whole numbers. So here's a little reminder about some of the polynomial functions. First degree is a linear function, second degree quadratic, third degree cubic, and our fourth degree is called a quartic function. Anything after that, we usually just say it's a polynomial with degree whatever, 5, 6, 7, whatever. Okay. Alright, so first of all we're going to go through long division, and I've put a separate problem from the one you're going to be doing on here. And so let's go ahead and take a look at long division. So this long division is just like your long division you did when you were in like 4th grade. And so we're going to divide, and when we set it up, we set our divisor here, and then our dividend 2x cubed. Now here's the thing, it says 2x cubed plus x minus 7. If you're missing a term, okay, like here we're missing x squared, so we need to put in 0x squared for that. You have to have that place value there. So plus x and minus 7. So when we're dividing, the first thing we're going to ask ourselves is, okay, what's 2x cubed? So we're going to focus on the first term here and the first term here. And we're going to divide them. So 2x cubed divided by x is 2x squared. So I'm going to put 2x squared over the x squared term. And then after I do that, just like in the long division you did when you're younger, we're going to multiply. So I'm going to multiply 2x squared times both of these. So when you do that, these two are always going to be the same. Okay? So you can get rid of it. 2x squared minus or times negative 2x is negative 4x squared. Now the next thing is, just like when you were doing long division when you were younger, we have to subtract. And a reminder, when you subtract, you have to change the signs because we're subtracting this whole quantity. So we're going to change the signs, which makes this one negative and this one positive. So now I have 0 plus 4x squared is 4x squared. And then I'll bring down my next term, so plus x. Okay, and so then we do the same thing. We're focusing on the 4x squared and focusing on x. So if I take 4x squared and divide by x, then we get a positive 4x. So we multiply again. 4x times x is 4x squared. 4x times negative 2 is negative 8x. And then once again we're going to subtract. So when I subtract, I'm going to change the signs. So I have this little note up here. It says don't forget. But when you subtract, you change the signs of a polynomial. So we get this part here, the 4x squared is going to be 0, and x plus 8x is 9x. and then we're going to bring down the negative 7. Okay. So then we focus on the 9x and the x. So 9x divided by x is a positive 9. We multiply them together. 9 times x is 9x. 9 times negative 2 is negative 18. So then once again, we're going to change the signs, or we're going to subtract by changing the signs, get negative 7 plus 18 is positive 11. So now, since I don't have anything else here, then I'm going to, this is my remainder. Okay, so whatever I get down here is my remainder. If this number was 0, that means that x minus 2 would be a factor of that. But since it's 11, it's not a factor. But then I'm going to say plus 11 over x minus 2. So that would be my final answer, that when I divide here, I'll get 2x squared plus 4x plus 9 plus my remainder over the divisor here. Okay. Alright, so there's long division. Now the other type of division that you've done is synthetic division. And so I'm actually going to show you synthetic division using the same polynomial or the same problem that we just used. So where I did all this work here for long division, when I do synthetic division, we don't have to do quite as much work. So here's how I set up synthetic division. First of all, we take what we're dividing by, and this must be linear. And it must be in the form x minus a. If it's not in that form, if there's a coefficient of x other than 1, if the degree of x is different than 1, you have to use long division. But in this case, I can use synthetic division. So we're going to put a little box here, okay? And the number that goes in that box is the 0 of the divisor. Okay? In other words, it's going to be the value of a. What makes that equal to 0? And it's always going to be the value of a that makes it equal to 0. So in this case, I'm dividing by x minus 2. So my number that goes here is going to be 2. Then I'm going to put the numbers, I'm going to put numbers here, and those numbers I put here are going to be the coefficients. Coefficient of x cubed, 2. Now once again, I don't have x squared there, so I have to put a 0 in to represent the x squared term. I have 1x, and then my constant, negative 7. Then I leave a space and draw a line. Okay? So in this little L-shaped thing here, I put the 0 of the divisor, or the value of a, which in this case is 2. Write down the coefficients of my dividend, 2, 0, 1, negative 7. Okay? Now, what we're going to do now is we're going to bring down the first term. This is always going to be the case, because 2x cubed divided by x is 2x squared. So we bring down this number. Then what we're going to do is we're going to multiply these two numbers together and put it up here in this next spot. So 2 times 2 is 4. Then you add these. So 0 plus 4 is 4. Then we do it again. We take this number here, multiply it by that one, the number I got, and it goes there. So 2 times 4 is 8. So 8 will go there. Then once again, we're going to add. 1 plus 8 is 9. All right, and then we do it again. 2 times 9 is 18. Okay, multiply it. 2 times 9 is 18. And then once again, we're going to combine them. Negative 7 plus 18 is 11. So here are the coefficients that I got up here in my answer doing long division. So synthetic division actually uses the same numbers. It's just a little quicker method. But unfortunately, the only time you can use it is if it's in the form x minus a. So it's a linear with no coefficient of x. Well, coefficient of x is just 1. So now here's how this works, okay? This number here then is always your remainder. This is my constant. All right, and then it goes from there. X to the first power, x to the second power, and so on. So my answer from this would be 2x squared plus 4x plus 9 plus 11 over x minus 2. The exact same answer. So, big number, important number here is my remainder. If that remainder is 0, it's a factor. If it's not, okay, then you have to write it as a fraction here. So there's long division and synthetic division. Now, we have what's called a division algorithm, and this is really nothing new. It's just that the way it's presented, the way it looks, is a little confusing. If I have a dividend, it's equal to the divisor times the quotient. Okay, well, what does that mean? That just means that if I take my dividend, 2x cubed plus x minus 7, it's equal to x minus 2, my divisor, times the quotient I get, okay, plus the remainder over it. So this is just, here's my dividend, okay, here's my function, my divisor, what I'm dividing it by, and the quotient that I get, plus the remainder. And so if we actually multiplied here and added, we would get our dividend. And then like I said, if the remainder is 0, when one polynomial is divided by another, then they are factors. So they want us to determine if it's a factor. So I'm going to use 2x minus 3 to see if it's a factor of this, 3x cubed minus 2x squared plus x minus 3. Now, when the divisor is a linear function, you can use synthetic substitution instead of long division. Now, here's something that's true. Now, I said you can only use synthetic if it's linear. Now, in this case here, I actually could use synthetic because all I'm trying to do is figure out if it's a factor. But if I wanted to actually divide, I couldn't use synthetic because it won't give me the correct numbers in my last line. Okay? So in this case, because there's not a 1 here in front of the x, I'm going to go ahead and use long division. So 2x minus 3 into 3x cubed minus 2x squared plus x minus 3. So we're going to do long division, and when we're all done, if we get 0 down here, then it's a factor. If we don't, then it's not. Okay, so it's we're going to go through and do this problem just so you can see the long division one more time. So 3x cubed divided by 2x, 3x squared. I don't think so. Okay, let's try that again. 3x cubed divided by 2x is, this isn't going to work out very good, 3 halves x squared. Alright, so we're going to end up working with some fractions here. So 3 halves x squared times 2x is 3x cubed. And 3 halves times 3 is negative 9 halves x squared. So I'm going to end up working with some fractions here. Not a big deal, we can do that. So we subtract, so we change the signs. And this is definitely a case where if I'm just trying to determine if it's a factor, that using synthetic division would be a lot easier. Okay? We get negative 2 plus 4.5 is 2.5, so this is 5. So this is going to be 5 halves x squared, and I bring down the next term plus x. Alright, so 5 halves divided by 2 is 5/4 x. So I multiply those together and I get 5 halves x squared, and 5/4 times negative 3 is negative 15 over 4 x. And since I'm running out of room, I'm going to move it over here. So when I subtract then, we get a negative here, positive here. So we have 1, which is 4 over 4. 4 plus 15 would be 19 over 4 x. and I gotta bring down the negative 3. So 19 over 4 divided by 2x is going to be equal to 19 over 8. So we do 2 times 19 over 8 is 19 over 4, x. And then 19 over 8 times negative 3 would be negative 57 over 8. Okay, all right, that's not a whole lot of fun. Now the big question is, when I subtract here, do I get 0? And negative 3 plus 57 over 8 is not equal to 0. So 2x minus 3 is not a factor. So what we're looking for is trying to get a remainder of 0 to see if it's a factor or not. So the remainder theorem basically says if a function is divided by a linear factor and I get a remainder of 0, or then the remainder is f of c. I should say that when I put c in for x, basically I get the number for the remainder. So what we're going to do then, it says find the remainder for this. Well, look at this. This says, and I'm focusing on this one right here, and we're going to divide it by x plus 1 still. That x to the 75th, that's huge. So if I actually tried to use synthetic division, I'd have a ton of zeros there, it would be a big mess. And so it's really easier just to substitute. So what I can do then is, I want to substitute the value of c. And remember, it's x minus c, so the value of c in this case, if it's x plus 1, then c would be equal to negative 1. It's what is the 0? What would give me 0 there? So I put in negative 1 here, to the 75th power, plus negative 1 to the 10th power, minus 1. And just a reminder then, if I take a negative 1, raise it to the power of 75, since 75 is an odd, I'll get negative 1. Take a negative 1, raise it to the even power, that's positive 1. So when I do this simple math here, negative 1 plus 1 is 0, and this is minus 1. So this would be my remainder if I divide this by x plus 1. So really, if I take that value of c and put it in for x, whatever number I get will be the remainder. So then even up here, it says determine whether it's a factor. I'm looking for the remainder. So in reality, I could find this 0, plug it in here for x, and whatever number I get would be the remainder. A little shortcut there. So we have another one that says find the remainder when this is divided by x minus 1. So when you're finding the remainder, you could plug the number in for x. In this case, since it's x minus 1, it'd be really easy to plug 1 in there. Or you could even use synthetic division, which actually goes pretty quick. So I bring down my 3. 1 times 3 is 3. Negative 4 plus 3 is negative 1. 1 times negative 1 is negative 1. This is 2. 3 plus negative 1 is 2. 1 times 2 is 2. And 1 plus 2 is 3. So here's my remainder when I divide. And so that would be the answer. So I'm going to stop the video here. You got examples 1 through 5, and I'll do examples 6 through 9 momentarily.